Good evening. My name is Wahid Lutfi. I'm going to share my screen so I could show you what I have for you today. Let's get started. And at my Web University Free Education videos, last time I talked about Python tuple or Python tuple data structure. So this video talks about the tuple data structure, but I'm going to just present you today a number of data structures in Python just to discuss those ones. Let's get started with that. First, let me show you the slide view. So on the Python data structure, there's a number of them, obviously, and I'm listing at least 6 of them here. The tuple data structure, which we talked about the other video last time, and tuple is read-only or a mutable data structure, which it means it's almost similar to list, but except list is mutable. You can change the content of an element. You can reference an element by indices and modify it. On tuple, you cannot modify the element. Although they both are in sequence and then they are indexable, dynamically you can, like array, you can point to and then index of an element and you can reference to it. You can always define a tuple or a list as new tuple, but or a new list, but you are not going to be able to modify a tuple index, like an element of, like, let's say the first element or 10 element or an nth element, you cannot modify it. So tuple is immutable data structure. But we're going to talk about each one of them in the specific examples. So tuple is a data structure in Python. List is another one. Set is another one. A string is another data type structure. And then class and objects are similar to extract in C, but class is object-oriented concept of programming and Python based on an object is an instance of a class, and a class is a template. We're going to discuss those as the with the detail as well. Data dictionary and arrays. I'm sorry. Data dictionary is basically or also data structure of Python, which we are going to just show you here. So let's go first with the tuple. A tuple, as I mentioned before, it's immutable in data structure. Immutable meaning that you cannot modify an element of a tuple. So T sub 0 cannot be modified to a new value, or T sub n element cannot be modified. Although there are sequence of iterable elements, you can just reference to any elements in a sequence, or you can indice it by some elements index, but you cannot change it. It is almost like read-only, a snapshot and point. So if you want to just have an array of elements to just work with it and modify it, and instead of a tuple, you create it as a read-only. I'm sorry, you create it as a list, which is mutable. You can modify it, but not tuple. So the next one that I'm going to discuss, Python list data structure. List, unlike tuple, list is mutable, which means you can change an element. So you can say T sub 0 is equal Wahid, and you can change it to a 5. You can change it to Lutfi. You can change it to anything. You can assign any value that is a valid data type for that Python programming language. Then you can assign it to an element of a list. And these are just allowing you, both tuples and list allow you to have multiple element of the same type, or the same type, or multiple of different data types, as well as duplicate elements. So all of those ones are allowed in the list and tuples. But with set, you don't have duplicate elements. Set is a sequence of elements that are unordered. They are not indexed like list and tuples. So you can just create a set, and then the set will just get rid of duplicate elements. So that's one way to convert tuples and list and get rid of their duplicates element by calling the set function and kind of like casting it. So the next data type that I'm talking about is a string. A string is almost like char in C and C++ or Java. And the data type that is there is basically multiple characters to put together, and it's made a string. A string is basically a combination of two or more characters. So it's one character is CHR, char, and then an array of char would be a string in C and C++ Java. But Python, you can have a string of one character, A, and then you can have a second character that would be also a string. As long as you put it in double quote, it will consider it as a string. So here, for example, the word Python is made up of 6 characters. So P sub 0, Python, if you assign it to a string called S, then you can say S of sub 0 is P. S of sub 1 is Y, and so on, until the last element. And you can also have for each string, because it allows you, like object-oriented programming, you can have the name on the object that you assign it. Once you declare a string called S1, S1 could have different methods available to it. For example, you can modify the word Python to be written all in uppercase. So you could say S1 dot upper, and then call the upper function with the left parenthesis, right parenthesis, or S1 dot lower, or S1 dot title. You can change these elements as you do, and then you can even just use a for range statement and other functions, and define your other method of manipulating that data. The data dictionary is also similar to like C and Java map functions. So you can allow basically it allows you to have key pair values like hashing code. So if you have, for example, an element, you're not using an index of 1 and 0s, like less than tuples. In data dictionary, you're allowed to write the word as a key, and then the value would be there. So for example, a key could be like let's say for capital of every country, if the keys are like Kabul for Afghanistan, the value is Afghanistan, the data dictionary, and the key would be Kabul, the capital. And then for Iran is and Tehran is Iran, and for India, New Delhi, and so on. And you can do it for USA, for example, Washington. So those key pair value, and you are basically getting assigned a value based on a key. And there's a lot of member and method and magic dunder methods that are available for them. We're going to show you all of that when it comes to time for this video. Python functional programming is a concept of procedure in Pascal, Ada kind of programming languages that even C and C++, all of them were basically, before C is still functional programming, and C++ is object-oriented programming. So there's functional programming and object-oriented programming. But before we go to the difference between the two, let's talk about classes and objects. So in life, everything can be identified as a class. For example, a human being, human is a class, employee is a class, a student is a class, and then teacher is a class, chair is a class, furniture is a class, car is a class, anything. And then, for example, for a human, an object would be an instance of that class human. So an employee is an object of it. A human being, just like, for example, myself, human being, I'm an instance of class human, because there are certain attributes for the object and certain methods that are applicable to that object. For example, if I say Wahid is a human, that an instance of a human class, then Wahid has certain properties or attributes. Wahid's name, Wahid's height, Wahid weight, Wahid age, Wahid, any information, username, password, identification, color of his skin, anything. So the method and that Wahid could do, I could teach, I could play soccer, I could read, I could write, I could walk, I could talk, and all those methods are applicable to me. Similarly, for an employee is a class of human. An employee could have first name, last name, employee ID, employee social security number, and then an employee can work and do certain functions of maybe developers, maybe just a business person. All of those functions that an employee can do, or work or task that can be happening, is the method that that object can do. So we talk about object-oriented programming in Python, and that these objects and classes, when you do it in Python interpreter, we have a lot of options to manipulate data. And as we go through these examples, I will show you how you can create object-oriented programming. But there are 4 paradigms in Python object-oriented programming that are very important to know. One of the paradigm is called abstract data type, or abstract data hiding. Basically, when you're just through abstraction, you're creating a class. The class itself and the name itself, you just say human. At this time, you hide all that details to say that this is a class. For example, you say class furniture. The data hiding is already in the class itself, but the transparency to the user, they just say, well, I know there's furniture, but I don't know the detail of it until I just reference some member functions or some methods that I use in that furniture class or that human class or something. So abstraction is there. And the next one is that polymorphism, which means multiple form. Poly means multiple, for polymorphism. So multi means multi-form, basically. Polymorphism, multiple forms. Multi is multiple. Form is form. Polymorphism allows you to have within the same object could react differently at different time. So one of the type of polymorphism, for example, for operator overloading or functional overloading, you can just have an operator class. If you pass 3 arguments to it, it would add up 3 numbers. And if you pass 1,000 arguments, then it will add up 1,000. So a calculator, that if you look at it, the abstraction of the calculator, the interface itself is hiding all those function calls that you could do summation, inversion, inverse function, or sine, cosine, anything. All you see is a button. When you click on the button, the function behind that one, it is going to be doing the actual work. So polymorphism, for example, summation or addition or multiplication, it could take multiple parameters and work differently. And sometimes you could just pass on function overloading, for example. On the same program, sometimes you could just add it, sometimes you could multiply it with the same operator. So depending on what you call it, for example, on polymorphism, you can also think of like a bird that sings, but then the parrot has voices, and that you could they could just say different things at the same time. And the pet could be a cat or could be a dog. And then when you pass in the dog, the sounds of the dog is different than the sound of the pet cat, right? So one of them could have a different sound, even though you're calling the sound, when you're calling the method sound to just be referenced. When the object is cat, it makes meow, and when the dogs, it roars. Those kind of things for the same function sound. So that is polymorphism. Inheritance is another paradigm of object-oriented programming, which allows you to just basically have a superclass and subclasses. And then that is how you do inheritances, parent-child relationship. And once you define a human being, an employee could be a subclass of a human being. A student could be a subclass of it. So the parent is having all that information like name and first name. The other information could be inherited, and subclass could be just having their own kind of methods and their own attributes and defined inside the subclass as well. So we talked about abstraction, polymorphisms, inheritance, and then encapsulation. Encapsulation is also similar to abstraction. However, encapsulation allow you to do more security kind of on your data hiding. So you can have protected class, public class, and private class. That is each one of those ones depend on how you reference those ones. You allow certain class or certain object to reference those data. And we are going to talk about object-oriented versus functional programming at some point. And that is the end of this video. I hope you like it, and I hope you learn something from it. And this is just a summary. We're going to go in detail on each one of these ones. And please stay tuned and make sure that you subscribe, so you're going to get informed on the videos as soon as I post it. Have a nice one. Thanks for watching. Take care. Bye-bye.